enabling the robot to adapt and learn autonomously from its interactions with new objects. And another remarkable aspect of the system is its affordability. With a cost of around $25,000, the researchers have developed a mobile manipulation hardware platform capable of safe and autonomous adaptation in unstructured environments. This makes it a viable option for widespread use in various settings. In a series of field tests conducted across 4 buildings on the CMU campus, the system interacted with 20 different articulated objects. The results were impressive. In less than an hour of online learning for each object, the system's success rate improved from 50% post-behavior cloning training to 95% following online adaptation. These results demonstrate the system's remarkable ability to learn and adapt in real time. The open-world mobile manipulation system's full-stack approach addresses both the hardware and software challenges of operating in diverse real-world scenarios. For their hardware, the researchers chose the Ranger Mini 2 from 𝐓𝐞𝐿 for its stability and omnidirectional velocity control, coupled with a high payload capacity, making it an ideal robot base. The manipulation tasks are handled by an X-arm, known for its high payload capacity and cost-effectiveness. This combination creates a versatile and robust platform for the robot's operations. The system's brain is a Jetson computer, orchestrating real-time communication between sensors, the base, the arm, and a server for large models. All visual data is captured through a D435 Intel RealSense camera, providing RGBD images, while a T265 Intel RealSense camera offers vital visual odometry for reinforcement learning trials. The introduction of the open-world mobile manipulation system is a milestone in the development of generalist robots capable of performing a variety of useful tasks in open-ended, unstructured environments. This breakthrough will soon allow regular robots to effectively assist in our daily lives, easily handling complex tasks throughout the dynamic and unpredictable environments we live in. The system's ability to adapt to different modes of articulation and physical parameters like weight and friction showcases its potential to handle a wide range of tasks in unstructured environments. Meanwhile, in a groundbreaking leap towards artificial general intelligence, Google's DeepMind just revealed its latest research on how their neural networks are edging towards an intelligence once reserved for the realm of science fiction: universal prediction. Shockingly, the team's innovative use of universal Turing machines to create training data allows these AI systems to swiftly adapt and master a wide array of tasks. But the heart of this evolution is meta-learning, a transformative approach enabling AI systems to rapidly assimilate new abilities from limited datasets. This method hinges on constructing task distributions of exceptional variety, ensuring AI models encounter diverse structural and patterned challenges. The ultimate goal is to develop universal representations, equipping systems to tackle an extensive range of problems and propelling humanity towards the zenith of AGI. In their paper named Learning Universal Predictors, the DeepMind team incorporates a Solomonoff induction inference system into neural networks via meta-learning. By harnessing UTMs renowned for epitomizing fully general computational systems, they're about to generate a rich tapestry of data that guides the neural networks towards universal prediction proficiency. But there's a catch, because while neural networks theoretically possess the capability for universal computation, practical training methods like stochastic gradient descent often restrain this potential. DeepMind's researchers bypass this impediment by using conventional architectures such as transformers and LSTMs, focusing instead on creating an optimal training data protocol with UTMs. This breakthrough heralds a new era where neural models that have been trained on data of universal complexity can still engage in transfer learning across domains, capturing a vast repository of adaptable patterns. DeepMind's vision extends to scaling their method using UTM data, potentially integrating it with extensive existing datasets and elevating the capabilities of future sequence models to unprecedented heights. In other news, it's also been leaked that Google is planning to launch a paid Gemini Advanced tier this week, with all new features, as well as streamlined Google AI tools to maintain a suite of collaborative capabilities. This means that Google will extend direct access to all of its AI models across all supported regions. But the real spotlight feature is its introduction of Gemini Advanced, equipped with Google's most capable AI model to date, the Ultra 1.0. Tailored for early adopters and those ready to harness the full potential of AI, Gemini Advanced offers groundbreaking capabilities like sophisticated coding assistance, logical reasoning, and nuanced instructions. It is poised to revolutionize creative collaboration. Furthermore, chat to supercharge your ideas is Google's new mantra, as Gemini integrates with Google Apps, allowing users to seamlessly harness AI for tasks ranging from email composition to event planning, all through a seamless interface on their phones. The Gemini app is set to launch on select devices with initial support for English, with more languages like Japanese and Korean to follow. Additionally, Google has enhanced its Maps application with a new AI-powered search feature, initially available to select local guides in the US. This feature, presumably powered by a model from the Gemini series, allows users to discover places based on their preferences. Users can ask for specific suggestions like vintage stores in San Francisco and receive tailored recommendations, including follow-up queries for related suggestions, such as dining options. This generative AI in Maps considers photos, ratings, and reviews to generate suggestions, adapting to changes like weather conditions to offer relevant alternatives. Google is also experimenting with integrating AI into its search offerings, notably through the Search Generative Experience. This ambitious project aims to provide AI-generated answers to search queries, potentially transforming web traffic dynamics. However, Google's CEO has expressed caution regarding the rollout of AI search, emphasizing that it's still in its early stages. While the company hasn't yet said which other countries would get the feature next, a wider rollout is expected to release in the coming weeks. When appropriate, the Search Generative Experience will show an AI-powered snapshot and give people a brief overview on any topic, including other factors to consider or any other helpful information. These snapshots are intended to serve as a starting point from which people can explore the World Wide Web. Overall, Google is doing its best to adapt to the artificial intelligence paradigm with all of its software products. But its users are becoming tired of its look-but-don't-touch release tendencies when it comes to new tools. Only time will tell if people will get tired of Google gatekeeping all of the newest technology.